Hi class, this is my second attempt at doing some kind of digital lesson here. This was for lesson 7-9. So I need to identify the precision unit of each measuring instrument. And if I look at this graduated cylinder, there is a big line here looking at 50. But I notice that there's some smaller ones in here that are every tenth of a milliliter. So I can go 50, 50.1, 50.2. So 0.1 milliliters is my precision unit that I know this. So I can measure this accurately to 0.1 milliliters when looking at it. Now if I look over at the thermometer, I also have that as a tenth of a unit here. So I look at that and it's a tenth of a degree Celsius. So once again, I have 0.1 degrees Celsius, okay? If I look at the ruler down here, this one has basically 1 centimeter, 2 centimeters, 3 centimeters, but it also has 4 dashes in between, which means that there's 5 total if you include getting to the next one. So this one is every 2/10 is the precision unit on it. In this case, it's 0.2 centimeters. I didn't give you the units on that one, but you should be able to tell that. Okay, and if I look at this pencil, assume that this pencil goes all the way back here to 0, and if I look at this, we go from 7 to 8, and then I have 8.1, 8.2. It doesn't quite make it to 8.3, and it looks like to me it's a little bit less than half in there. So I'm going to estimate this one at 8.2, and I'm going to say 0.24. It's a little bit less than halfway in there. 8.24 centimeters is the length of that pencil. Now, what this main lesson is about significant digits. And I have given 1, 2, and 3 significant digits in this particular lesson. Now, the rules for significant digits are as follows. Any digit from 1 to 9 are always significant. So that's really easy. It's the zeros that are the difficult ones. Now, so if you see anywhere 1, 2, 3, 4, 5, 6, 7, 8, 9, it is always a significant digit. So zeros sometimes are and sometimes aren't. Now, if they're between any other 2 significant digits, they are also always significant. So if you have a 0, let's say 1.09, well, that one's going to have 3 significant digits because it's between a 1 and a 9. All right. Now, 1 or more additional zeros to the right of both the decimal place and another significant digit are 0. So let's say I have 1.500. So this is these zeros are to the right of the decimal place, and they are right of another significant digit, like the 5. And so these zeros are also significant. So I have 1 significant, 2 significant, 3, and 4. This would be 4 significant digits. Okay? So zeros used solely for spacing the decimal point are not significant. So in other words, if I have the number 500, those 2 zeros, first of all, they're not to the right of the decimal place. So this one only has 1 significant digit. Okay? As well as, let's see, that's basically what we're looking at here, spacing the decimal point. All right, so we need to do some practice for you guys to do that on your own. Go ahead and do this problem and then check to see, stop the recording right now, and then do as best as you can with this by following the rules, and then check with me, continue to watch the video as I explain this. So here I go. So this one, we have 1, 2, 3 significant digits. None of them are zeros, so the answer to this one is 3. All right. This one has 1 significant digit. The zeros to the right of it are just placeholders. This has 1 significant digit. Okay. This one has 1, 2, 3, 4 significant digits. That 0 is not only to the right of the decimal place, but it is also to the right of a significant digit. Okay, this one, we have 1, 2, 3, 4, again, significant digits. Those 2 zeros are between a 5 and a 1, which are significant. So if you're between significant digits, that makes you significant as well. All right. This one has 1, 2, 3, 4, 5, 6 significant digits. Again, those zeros are significant if they're between other digits. Okay. All right, this one's a little bit tricky for the next one here. This one, we only have one significant digit. The other ones are all placeholders. And although two of them are to the right of the decimal place, they do not have any significant digits to the left of them. They're not right of any significant digits. So this one just has one. This one has two significant digits. Again, those last four are just placeholders. They are not to the right of the decimal point, so they are not significant. This one has 1, 2, 3, 4 significant digits. None of them are zeros. This one has 1, 2, 3, 4, 5, 6. This one, those zeros are significant because they are not only to the right of the decimal place, but right of some significant digits. And this one has 1, 2, 3, 4, 5, 6. Everything in there is significant. Those zeros are between significant digits, making them significant as well. This one has 1, 2, 3 significant digits. Those significant digits, that zero is significant because it is to the right of the decimal and is to the right of a significant digit. This one only has 2 significant digits. All those zeros are not to the right of any other significant digits, so none of them are significant. They are just placeholders. Okay, so now we're going to put this to work. Now that you know the rules of significant digits, when we're writing our answer, this is really important. I've always told you, round to the nearest tenth, or round to the nearest unit, or round to the nearest hundredth. Well, I'm not going to tell you that anymore. There's a rule. You have to follow the rules of significant digits. So if I have 3 packages and I want to find the combined weight of them, I basically add them up. We have 5.125, 6.75, and 4.6. And if I add them up here, I find that I get 16.475. Now that's not my correct answer because it doesn't take in the correct number of significant digits. If I look at these 3 numbers, which of them has the least amount of significant digits? We have 4 for this one, 3 for this one, and 2 for this one. This is the important one that has 2 significant digits because the one with the least amount tells me the correct number of significant digits for my answer. And so my answer, if I look I have 1 significant digit here, 2 significant digits, I'm done. The answer is 16 pounds. I do not know, because my initial measurements were the least accurate one had only 2 significant digits right here. That means my answer is only as accurate as 2 significant digits. So I really cannot be any more accurate than that. Okay, doing the next one, we have a rectangle has a base and a height of 10.3 and 4.5. I'm going to give the area, well, we know it's base times height, so I'm going to have 10.3 times 4.5. I multiply those out, and let's see, I get 15 here, and that gives me 1, 5, and 4 times 3 is 12, and then 4 times 1 is 4. I add those up, I'm running out of room here, 5, 3, 6, and 4, and my decimal place, it has 2 decimal places. There's 1 here and 1 here, so I put the decimal right here, 46.35. But again, I have 3 significant digits here, and I have 2 significant digits with one of them. So my answer can only have whatever one has the least amount, which is 2 significant digits. My answer is going to be 46 square centimeters. I cannot know this any more accurately than that because of the significant digits that were given in the problem. All right, moving on to the next one here. Subtracting, I've got 3.48 and I'm subtracting 0.2. If I subtract, I get 3.28. But again, this one has one significant digit. So I can't be any more accurate than knowing one. So my answer is 3 liters. All right. Now I have 0.45 meters divided by 0.8 meters. Well, that's the same thing as move the decimal one place for each one. No, I didn't leave enough room here. Let's do this a little farther down here. So I have a decimal place here. 8 goes into 45 5 times. Multiply to get 40. I subtract and I get 5. I have a 0, bring down a 0. 8 goes into 50 6 times. And I multiply and I get a 2. Bring down a 0. 8 goes into 20 twice. Subtract and I've got a 4. And now I have 8 goes into 40 5 times. And I'm going to get my answer there. Now, I went probably much more work than I needed to do, because if I look at it, this one, the 0.8 meters, only has one significant digit. So my answer can only have one. So I'm going to get 0. Now it says 0.56. I need to, if I look at that 6, that 5 should be rounding up to 0.6 is my answer. 0.6, and the meters divide themselves out, and I get 0.6 as my answer. And I only know it to one significant digit, so my answer should only have one. All right, now I want you to do this classwork down here, and I will attach that those homework assignments for those of you who don't have your textbook with the answers in them, so you can do that.